Variation deals with examining and measuring relationships among variables. This will be useful in later years in your academic pursuit. There are 4 types of variation. There are 4 types. Four types of variation. Number 1, we have indirect. We have direct variation. Let me write that on the board. We are done with compound interest. I'll encourage you to pick up your text and do and lay your hands on as many questions as possible. Variation. Now, I said number 1, we have direct. We have indirect. Number 3, we have joint. And we also have partial. These are the 4 types of variation you will experience or you will encounter in questions under variation. Number 1, when a variable, let's say quality, has a direct variation or varies directly as the demand, the implication is any change in one variable triggers a commensurate change in the same direction. Let me say that again. For the first type of variation, variation means relationship, like I've said. Variation, another word for variation is relationship. And it's good for you to understand the grammatical aspect of it. Sometimes it will help you when you are dealing with the numbers. Variation, like I said, deals with relationship. And I said again that relationship, if it is a direct relationship, a little change in one of the variables that are experiencing similar relationship or that are experiencing direct variation, a little change in one variable triggers a commensurate change in the other variable. And I give example of quality and demand. When the quality of a product is good, you will expect that the demand for that product will also be very, very high. And so that kind of relationship is called direct relationship, and it is usually represented as Q. Since we are dealing with quality, varies directly as demand. The quality varies directly as the demand. A change in quality will bring about a downward change in quality will bring about a downward change in demand. But when you raise the quality, you will see that the demand will also soar accordingly. So you must understand that that's what we mean by direct variation. And if you want to change this, introduce a constant. The constant is introduced this way: Q equals to KD. Q equals to KD. This one is for direct variation. Let's take a question. The question says, if P is a variable, if P varies directly as R, P equals to 10 when R equals to 20. Find the law connecting P and R and determine R when P equals to 12.5. Again, let's take the question. If P varies directly as R, P equals to 10 when R equals to 20. Find the law that is connecting the P and R and determine R when P equals to 12.5. Let's quickly answer this question. I will go to the other types of variation. Now, we're told that P and R enjoy direct variation. When you see a representation like this, what it means, this is the way to read it. P varies directly as R. P varies directly as R. That's the way it's read. In the question, we're told that P varies directly as R, and we're told again that P equals to 10 when R equals to 20. Then we're told to find the law. Find the law connecting P and R. Find the law that is connecting the two variables and determine R when P is 12.5. When P is 12.5. The first thing you do is to determine the constant. P varies directly as R. So, if you want to introduce the constant, it becomes P is equal to KR. We're told when P is 10, R is 20. So you can say 10 equals to K20. KR means K times R. For purpose of those who will see ask questions. K times 20. So we have 10 equals to 20K. That's the relationship between both of them. And so K eventually, you can say your constant is half. Let me do it the way everybody will be able to go along with us. What you do, divide both sides. Because some will say, how did you get that? Divide both sides by 20. So we have 10 divided by 20 equals to 20K divided by 20. So K equals to half or 0.5. So the connecting, the first question, A1, and this is the 2. The connecting law between P and R is P equals to R over 2. Or better still, 0.5 R. The only one you write will be correct. How did I get that? We already said P equals to KR. Now we know K. K is half or 0.5. So is that how you say R over 2 or 0.5 R? Then the second question says determine R when P equals to 12.5. Alright? So you now say that means you should make R subject of the formula. If P equals to KR, then you divide both sides by K. Divide through by K. You have P over K equals to KR over K. So R, therefore, R equals to P over K. So then we're asked to find R. If R equals to P over K, then R equals to 12.5 divided by 0.5. You can change it to fractions instead of decimal. So that's 12.5 is 12.5, which again is 25 over 2 divided by half. Again, 25 divided by 2 times 2 over 1. And then the final answer will be 25. The final answer will be 25. So R is 25. This is direct variation. The second variation we will look at is indirect variation. Indirect. When a variable, for instance, demand, varies inversely as supply, the implication is any change in one variable triggers an opposite reaction and is in the opposite direction. Let's say, for instance, it happens in every market, not only in Nigerian market. When a producer of a particular product notices that there is a rise in demand, you find out that the price will start jumping up. But again, it is possible that when there is enough demand, the price falls. Just like in the case of secondary schools. When I was in secondary school, in the whole of Ibadan, I'm not sure we have up to 5 private schools. I'm not sure. I'm talking of in the 80s. But now, you probably have a private secondary school on every street. That's what happens in Lagos, for instance. And so the quality has dropped, and because of the drop in quality, again, it has also affected the cost of going to some of these schools. But again, you see some schools that are still very, very expensive. But what am I saying? I'm saying that there is a possibility of a rise in one variable leading to the downward trend in another variable. I mean, if that situation expresses itself, that is called indirect variation. It is called indirect variation. Let's look at the second one. The second one is indirect variation. This is it. And if this happens, what we're going to have, let's say we're looking at A and B. If A varies inversely or indirectly, varies inversely or indirectly as B. If A varies inversely or indirectly as B, it is represented like this. If I write something on this for you in mathematics, what I'm simply telling you is the relationship between A and B is an inverse relationship. The variation is an inverse variation. And just like we did for the direct variation, to introduce a constant, it becomes A equals to K over B. Introducing a constant, it becomes A equals to K over B. Let's quickly look at an example to deepen our understanding of this particular aspect of this question. Look at this. If B varies inversely as G, if B varies inversely as G, B equals to 5, G equals to 4. Find the law connecting B and G, and find G when B equals to 10. Let's take it one after the other. The question says, if B varies inversely as G, this is an example, but we're looking at a question. It says B varies inversely as G, and we're told that B equals to 5 and G equals to 4. We are required to find the connecting relationship Not just that, we will also be required to determine G. Find G. Find G when B equals to 10. Find G when B equals to 10. So the first thing you do is you will find the connecting relationship between B and G. Now, if you introduce a constant to this relationship, it will become B equals to K over G. We're told that B is 5 and G is 4. G is 4. So we have K over 4. Again, you cross multiply and K becomes 5 times 4, which is 20. So based on this, the connecting relationship will be B equals to 20 over G. The connecting relationship will be B equals to 20 over G, since K has been determined as 20. Then if you now want to answer the second question, which says find G when B is 10. Find G when B is 10. What you do again is to make G subject to the formula. To make G subject to the formula, you cross multiply. So we have BG equals to 1 times 20. When you do that, you have BG equals to 20. But we are trying to make G subject to the formula. So you divide both sides. Divide through by B. So BG over B equals to 20 over B. B goes here, so you have G left. So G can now be calculated. Our B is 10. So you have 20 over 10. So G is 2. So when B is 10, our G is 2. And the connecting relationship between these two variables is B equals to 20 over G. The good part of video is I don't have to wait for you to copy it. You always have it with you. You can rewind, you can pause, you can slow me down. Let's go to the third one, which is joint variation. What is joint variation? Joint variation exists when one variable is jointly affected by more than one variable. A joint variation exists when one variable is jointly affected by more than one variable. It is just like direct variation, except for the fact that the determinant variables are more than one. It has only one constant as well. Let me repeat that. Joint variation is just like direct variation. The only difference is that the determinant variables are more than one, and it has only one constant as well. Look at this question. M varies jointly as the square of R and the square root of T. Look at this. Let's look at joint variation. Joint. Now look at that question I just repeated now. It says M varies jointly as the square of R. M varies jointly as the square of R. This is square of R. And the square root of T. And the square root of T. As the square of R and the square root of T. That is, which is what I've represented. And if you are going to introduce a constant, it's just one single constant, which is usually represented with K. KR squared square root T. KR squared square root T. So let's take this question. If E varies jointly as G, the square of N and the square root of U. If E varies jointly as G, comma, the square of N, comma, and the square root of U. When E equals to 200, G is 2, N is 2, U is 25. Determine the value of N when E equals to 540, G equals to 3, and U equals to 16. What we do first is, let's represent it mathematically. We're told that E varies jointly as G, number 1, the square of N, number 2, and the square root of U. The square root of U. If we have this kind of scenario, then E is written as this: KGN squared root U. KGN square root U, in introducing the constant. So the first thing you try to do after you have gotten this kind of a connecting relationship is to determine the value of K. And we were given the initial values. We were told that E is 200. We were told that G is 2, N is 2, and then U is 25. This initial set of values will help us to determine K. Then we're asked to find N when E is 540, G is 3, and U is 16. So let us first of all determine the value of K using these values. E is 200, K, G is 2 times 2, N is 2, that's N squared, that's 2 squared, times the square root of U, which is 25. Again, we have 200 on this side equals to K times 2, 2 raised to power 2 is 4, the square root of 25 is 5. And then you multiply all of this together, you still have 200 on this side, which is equals to K times 40. 2 times 4 is 8, 8 times 5 is 40. For you to now determine K, you divide through by 40. So you have 200 divided by 40 equals to K40 over 40. And then this goes, then K eventually becomes 5. Because 0 cancels 0, 4 here 1, 4 in 25. So our K equals to 5. Our K equals to 5. Now, I will determine K. You can now say E equals to 5, using this formula, 5gn squared root U. That's the connecting formula. E equals to 5gn squared root U, because we have been able to determine our K. Now, you will substitute and determine the value of N using these values that have been provided for us. So we have E equals to 540, 5 times G, G is 3, N is unknown, we have N squared, and then we have root 16. Again, the next one, we have 540 equals to 5 times 3, which is 15, times N squared times 4, times 4. So, because the square root of 16 is 4. Again, you have 540 on this side, multiply 15 and 4 together, you will have 4 times 5, 0, and 4 times 5 is 20, right 0 carry 2, 4 times 1, 4 plus 2, you have 60, N squared. You divide both sides by 60, divide by 60. 540 over 60 equals to 60 N squared over 60. If you cut 60, you cut 60 on this side, then you have 6 here 1 in 54 9. So eventually you have N squared equals to 9. But if you look at the question, it did not ask you to determine N squared. It asked you to determine N, but you have discovered N squared here. So to determine N, what you do is you will take the square root of both sides. Take the square root of both sides. I hope the camera is picking this. Take the square root of both sides. So you have the square root of N squared and the square root of 9. The square root of N squared will give you N. The square root of 9 will give you 3. So the value of N in this question is 3. Let me quickly run through so that we can go on to the partial variation. I said there are 4 types of variation. We have direct, we have indirect or inverse, we have joint variation, and we have partial variation. We've treated 3. The third one we just finished now is joint variation. And I said it's just like direct variation in the sense that it has only one constant, but there are more determinant variables on the other side of one variable. And like in this case we've seen, the question says M varies jointly as the square of r and the root of t, the square root of t. And in the question we treated, we said E varies jointly as g, n squared, and the square root of u. And we substituted the values that were given to us initially so that we can determine the constant. E was given as 200 and all other values were given as stated on the board. We substituted those values and we're able to get our k. If you look at the way we've done it, just follow the process, you won't have any problem. G is 2, n is 2, and since n is n squared, we have 2 raised to power 2. U is 25, and then we have the square root of 25. The 200 is still 200, k is k all round, we have 2, then 2 squared becomes 4, square root of 25 becomes 5. We multiply 2, 4, and 5, and we got 40. And then you divide 3 by 40, 200 divided by 40 gives you 5. K 40 divided by 40 gives you k, so k equals 5. Then you now use that constant you've gotten to determine n that the question is requiring from us. If E is 540, G is 3, and U is 16. When we substituted all of those values, these 3 values that were given, we were able to determine n. And our n, as we have gotten here, is equal to 3. Our n equals to 3. So we're going now straight to partial variation. Partial variation. This one is a little bit different from the rest in the sense that you require 2 constants. You require 2 constants. So I will implore you that you listen and pay attention to the uttermost for this one. Out of the 4, only partial variation has 2 constants. All right. Okay. This type of variation has 2 types of constant, usually represented by C and K. Partial variation is usually represented by C and K. C and K. And the key word is partly. Partly. And there is a minimum of 3 variables. The key word is partly, and it's a minimum of 3 variables. X varies partly as y squared. I'm taking an example. X varies partly as y squared and partly inversely as z. Look at that. X varies partly as y squared and partly inversely as z. When y equals to 4, z equals to 6, x equals to 19. When y equals to 5 and z equals to 12, x equals to 35. Find x when y equals to 6 and z equals to 10. The first 2 sets of values are substituted to determine the unknown constants through simultaneous equation. Again, we have not treated the simultaneous equation in this series of lectures, but shortly we will be looking at that. But let me explain it, and then I will explain a little bit more when we get to simultaneous equation. Look at the question. It says x varies partly. X varies partly as y squared. X varies partly as y squared, and is written as this. X varies partly as y squared and inversely as z. And inversely as z. This is the way to represent this kind of question. The second variable is added to the first one, and the variation sign is still there. And when you want to introduce the constant, it usually has 2 constants. 2 constants. So we have x equals to the first constant ky squared plus c over z. Let me repeat that. If a situation presents itself, like in this case, when you have three variables that are partially variated, like in this case, we're told that x varies partially as y squared and inversely as 1 as z. That's why we have 1 over z, because the relationship between x and z is inverse. The relationship between x and y is direct. That's why we didn't invert this one. But it is a partial variation between both of them. It's not joint. If it is joint, there will be no plus. But if it is partial, there will be a plus between the variables that are concerned. And when you are changing this variation sign to equality sign, you will introduce two constants. K and C are usually used to represent constants. Alright? So, you will now use the two values that have been supplied to determine the constants. So let's take the first one. The first one we're given as, let me write here. We're told that y equals to 4, comma, z equals to 6, and x equals to 19. Again, y equals to 5, z equals to 12, and x equals to 35. So you will use these two sets of values to determine our constant. All right, so let's start. This is the connecting